Good morning students, how are you all? Today we are here to discuss another important topic related to CSE pre, and in previous year also you can say two questions has came from this topic, and that is structure of atmosphere. Now if we talk about a structure of atmosphere, so as we know that our atmosphere is extended from 0 kilometer to thousands of kilometer, means it has been divided into layer. And the most important thing is that in the previous lecture what we saw, the composition of atmosphere along with the greenhouse gases, greenhouse effect, global warming and the effects of global warming. So today we are going to see that how the whole atmosphere of Earth has been divided into different layers, and those are having the particular characteristic, and you can say and play a very vital role in our day-to-day life. So let's draw the structure of atmosphere. This is the structure of atmosphere, in which the lowermost layer is considered as troposphere, then after stratosphere, mesosphere, ionosphere, thermosphere and exosphere. Let me tell you one more thing, that in few books you are going to find, instead of basically thermosphere and ionosphere separately, in few books only you are going to find thermosphere, and in that thermosphere you will find written ionosphere in the lower part. So never get confused. Now see, basically the lowermost is troposphere, and the boundary of troposphere and stratosphere is considered as tropopause, stratopause and mesospause. Above mesospause, now the question comes in your mind that what about ionospause, thermospause, all these? So no such pause is there beyond the mesospause, as because the density of the atmosphere becomes very negligible and these layers coincide within each other. That's why only three boundaries will be there: tropos, stratos and mesos. Now we are going to see the characteristics of each layer one by one, like troposphere. Now if you consider the troposphere, the boundary of troposphere, you can see that it is given over 12 to 15 kilometer and 6 to 9 kilometer. 12 to 15 kilometer is over equator and 6 to 9 kilometer is of pole. Now the question comes, why? So let's have a look. Basically, the boundary of troposphere is determined by convectional currents. Now the question comes, convectional current means, as you know that the energy within any medium is transferred by three means, either conduction, convection or radiation. Energy coming from sun is radiation, and conduction take place in solid where the energy is transferred from one medium to another, one particle to the another particle without leaving the original place. On the other hand, if we see the convection part, here the energy is taken with the particles, means the particle move with the energy, and this process is considered as convection, which take place in liquid and gases. Now here, this is the earth's surface, and as I told you, the boundary of troposphere is determined by convectional currents. That's why it is more over equator and less over poles. As because we know that over equator the temperature is high. When the temperature will be high, the air near to the surface are going to be heated up with the process of conduction, as because they are stick with the surface, and due to heating they will expand and they will start rising up. So as because equator is having the maximum heating, so the air which is going to rise up will rise till the maximum height. Sometime instead of 15 you can find 18 kilometer also, due to the high convective layers. On the other hand, the pole is having very less temperature, so the convectional currents which are going to get generated, they will be lifted till 6 to 9 kilometer only. Like if I give you the example, when we boil the milk, so on maximum flame the boiling level in the milk come to the topmost part of the pot, but when we are going to little bit lower down the flame, the boiling level will come down, and at the lowest flame the boiling level will be at the lowest. Means on equator the energy is maximum, so the lifting of air will be maximum. In mid latitude areas the temperature is you can say neither too high nor too low, so the lifting will be in the mid, and on the pole the heating is very less. That's why the height of the currents is low, and when we will draw the curve it will always come slanting. Means the boundary of troposphere is determined by the convectional currents, means surface heating. This is the first part of the troposphere. Now second, if we say more than 90% of the atmospheric density is present in troposphere only. Now the question comes, why? So as because the gravity of the earth will remain maximum near the surface, and as we are going to move up in the upper atmosphere, the gravity will go on decreasing, which means that basically with the increase in gravity the density is going to decrease. And the second thing, the heavy gases and the particles will remain near to the surface and the lighter one will remain in the upper atmosphere. That's why the maximum density of the atmospheric layer troposphere has. Next, all the weather phenomena. Next point, that all the weather phenomena take place in this layer only, like cloud formation, rainfall, or you can say monsoon, cyclone, everything. Even the lifting of the air is going to take place till the tropopause only, and after that vertical lifting the horizontal movement will start. Now the question comes why? So let's have a look. This is as because with the increase in atmosphere height, the temperature decreases, and the temperature decreases at the rate of 1 degree Celsius per 165 meter or 6.5 degrees Celsius per kilometer, and this condition is considered as normal environmental lapse rate. Simply means normal decrease in the temperature with the height. Suppose a air parcel is having 30-degree temperature over the surface, okay, and when we are going to lift that particular air parcel till 165 meter, the temperature is going to decrease by 1 degree Celsius and it will become 29. If we are going to lift that air parcel to 1 kilometer, the temperature is going to decrease by 6.5 degrees Celsius and it will reach 23.5, and this decrease in temperature is considered as normal lapse rate, environmental lapse rate, or normal environmental lapse rate. Now, as I told you that maximum vertical lifting is going to take place till tropopause. After that, the horizontal movement will start. Now the question comes why? So as the air will be lifted, the normal lapse rate is going to applied, and after reaching till tropopause, it is going to get, you can say, heavier and cold, but it can't come down from the same way because the traffic is one way. Now the heavier air will start diverging in either right or left part, and a convective layer is going to get formed. Simply. Is it clear? And if I tell you about the name of the troposphere, why it has been named? So due to turbulence and instability in the layer, it is considered as tropos, and that's why troposphere, because all the weather phenomena are taking place in this layer, and when all the weather phenomena will take place, then surely there is going to be a turbulence. Second thing, normal lapse rate is there, means 1 kg of air, if it is having 4 gram of water vapor, then it is going to be considered as normal air. But as our atmosphere is an open system rather than closed, so the amount of water vapor is going to be always in normal case, it's not necessary. So sometime the water vapor is going to be more than the normal, sometime the water vapor is going to be less than the normal. Means if the water vapor will become more, it will be considered as wet air, and if the water vapor is less, it is going to be considered as dry air. So the question comes in our mind, there must be the lapse rate of wet air also, and there must be a lapse rate of dry air also. So yes, and this lapse rate is considered as wet adiabatic lapse rate and dry adiabatic lapse rate. The wet adiabatic lapse rate is 3 to 4 degrees Celsius per kilometer, and the dry adiabatic lapse rate is 10 degrees Celsius per kilometer. Now the question comes, how? So water vapor, for the conversion of water to water vapor, latent heat is consumed, as we know, the heat and heat. Now as the air is going to lifted up, the two water vapor molecules or the water molecules has been separated, as because in between them there is latent heat. Okay, Now when they will move up, the process of condensation will start, and when the process of condensation will start, both the molecules are going to move towards each other. Now when they will just come towards each other, the latent heat which was consumed to change the state of water to water vapor will release, and due to release of latent heat, the ultimate decrease of temperature is going to be less. How? Let's see. Suppose the decrease in temperature was 6.5 degrees Celsius as the lifting of air took place on 1 kilometer, but due to release of energy, 2 degree Celsius temperature inside the air increased due to release of latent heat which was absorbed in water vapor. So ultimate decrease of temperature will be minus 6.5 plus 2 degree, so it will be minus 4 degree Celsius. Understood? That's why the wet adiabatic lapse rate is 3 to 4 degrees Celsius per kilometer. On the other hand, if we talk about dry adiabatic lapse rate, dry means the air is not having any water vapor or less than normal. So when the water vapor will be less, which means the latent heat will be also less. So the cooling of air is going to be very rapid, means no release of latent heat. That's why the dry air cools fast due to absence of latent heat, and it is 10 degrees Celsius per kilometer. Understood? So wet adiabatic lapse rate 3 to 4 degrees Celsius means when the water vapor will be more, latent heat will be more, so ultimate decrease in temperature will be less. Dry adiabatic lapse rate, less the water vapor, less the latent heat. So basically the lapse of temperature will be very rapid and it will be 10 degrees Celsius per kilometer. Now the question comes, sir, what is adiabatic? So adiabatic cooling is nothing but in the same condition, means when the air is forcefully lifted. Basically we know the lifting of air is due to the temperature and expansion, but when the temperature is not increasing, the expansion of air is not taking place, means water vapor content is not also changing, and in the same condition when the air is going to be lifted up, it is forcefully cooled down, means this type of cooling is going to take place in the hilly regions where with the movement, when the air will encounter a slope, it will rise up automatically, or when the cold air and the warm air will meet, the cold air will subside down and the warmer air is going to be lifted up. Then this type of cooling is going to take place, means without any external change, internal change of the air, when it is lifted, then it is considered as adiabatic cooling. Clear? After this, now according to the normal lapse rate, there must be a temperature of tropopause. So if we talk about the average temperature of tropopause, it is minus 80 to minus 90 degrees Celsius. How? Let's have a look. Equator is having normal temperature of 40 degree plus, and if we are going to move over a height of 15 kilometer, 15 multiplied by 6.5 means minus 97.5. Minus 97.5 plus 40 degree. What will be the temperature? Minus 57.5. Let's make it 60. Minus 60 degrees Celsius. Okay. Equator is having this much temperature. Pole, already minus 60 degree is there. Now when the air is going to lifted up, the temperature is going to fall according to the normal lapse rate. So 6.5 multiplied by 9 means 58.5. Let us make it minus 60. Minus 60 minus 60 will be minus 120. Minus 120 minus 60 minus 180. And minus 180 divided by 2 minus 90. But if you remember, from minus 57.5 we took the average of minus 60, and from minus 58.5 we took the average of minus 60. So as we decrease the temperature, so here we increase the temperature. So the average temperature of tropopause is minus 80 to minus 90. But mind it, over equator it is near about minus 50 to minus 60. Over pole it is near about minus 100 to minus 120. And the one more thing, the temperature of tropopause is basically a dynamic thing. As the temperature of surface air is going to determine the temperature of tropopause, and it will change season to season, day by day, amount of water vapor content. So it is not fixed, but as because we are seeing the atmosphere in an ideal condition, so we have to take the average. Okay, but practically the temperature is not always minus 60 or minus 120. It used to vary depending upon the temperature of the air, depending upon the location of the place where the temperature is determined by the local factors also. And those factors we are going to deal in the coming classes of general circulation of atmosphere. Now after troposphere, let's see stratosphere. Stratosphere is the second layer of the Earth's atmosphere, and stratos means stagnant in nature. Basically no weather phenomena take place in this layer, and that's why the aeroplanes fly in this layer only. Mind it. Now the question comes, why? So we know for flying of airplane, or basically for a smooth movement of traffic, we need a clear weather. Like if you have noticed, the traffic is more fast in summer season rather than in winter season. Why? Due to the presence of fog during winter. And fog is technically a type of cloud which is stratus cloud, which is found near to the surface. Now this means in foggy days during winter season, the traffic is very slow, and you can say accidents take place. Which means if the cloud is present on the surface, it is, you can say, giving trouble to the traffic and increasing the number of accidents. Means in the sky also, if we are going to move in clouds, the vulnerability to accidents will increase, or you can say the traffic smoothness will decrease. But as all the weather phenomena take place in troposphere, which means the stratosphere is going to be cloud free, and when it will be cloud free, the traffic will be smooth and less prone to accidents. That's why the aeroplanes fly in stratosphere. On paper, mind it. Practically they fly in troposphere. Now the question comes, sir, how? So as because every time in the sky there is no clouds, and the most important thing, when there are clouds in the sky during monsoon or winter season, if you have noticed, either we cancel the flights, or the flights are delayed, which means practically they are flying in troposphere. But as on paper we have written all the weather phenomena in troposphere, so we will fly the planes in stratosphere. So always mind it, the you can say characteristics and the importance of the layers on paper means let the value be x, and practically both are different things. Second part, in this layer with increase in height the temperature increases, and reaching over to stratopause the temperature reaches to 0 degrees Celsius. Now the question comes, how? Because as we are moving in atmosphere vertically, the density is decreasing, and we know density and temperature, they move side by side. More the density, more the temperature, less the density, less the temperature, means intermolecular space. So here the density is decreasing, so the temperature must decrease, and here rather than decrease it is increasing. Why? So this increase in temperature is due to the presence of ozone layer in this sphere. And we know the main work of ozone is to prevent the ultraviolet rays from coming to Earth's surface, or basically to absorb the ultraviolet. So from 15 to 30 the temperature almost remains stagnant, but beyond 30 due to the excessive presence of ozone layer and the absorption of ultraviolet, the temperature suddenly increases, and which was minus 90 or minus 80 over tropopause reaches to 0 degrees Celsius. Clear? And this increase in temperature with height is considered as temperature inversion. Temperature inversion. Mind it. Inversion means just opposite. Temperature means the inversion of temperature took place. And the normal lapse rate, as we saw, is with increase in height the temperature is decreasing. But in stratosphere with height the temperature is increasing. And this increase in temperature is considered as the phenomena of temperature inversion. And in exam also it is asked that in which layer of atmosphere the phenomena or event of temperature inversion take place. So it's stratosphere. Now the question in your mind, sir, is the temperature inversion taking place only in stratosphere and not in troposphere? So no, the temperature inversion case take place in troposphere also, but in specific conditions. Like in troposphere, the temperature inversion case are mainly of 3 types. And what are they? One is radiational inversion, second one is valley inversion, and the third one is advection inversion. Let me give you a brief about the radiational inversion, valley inversion, and the advection inversion. Radiational inversion take place during the long winter nights, where due to long night the loss, or you can say the terrestrial radiation loss, is very high or over a long duration of time, due to which what happens, the surface of the earth cools down and due to cooling down of the surface, the air near to the surface is also cooled down by the process of conduction. But the air above the particular air column remains in normal temperature. Let me give you a look. Suppose this is Earth's surface and there are two columns of air. Okay. Now we know the specific heat of land and sea. The specific heat of land is very less and water is very high. Land heats up very fast and cools down very fast. And on the other hand, water takes time to heat up and cools down. So basically during long nights, or you can say during winter season, the daytime is shorter, means the insolation or the income to the Earth's surface in the form of solar energy is less, of merely 10 hours, or you can say 11 hours. But the loss, the expenditure during night is of more than 14 hours. So what happens? The income is less, expenditure is more. So though ultimately what happens? The Earth's surface cools down, and the supposed temperature of Earth's surface has reached to 3 degree to 4 degrees Celsius. Now the air column which is just above the Earth's surface will also cool down and its temperature will become 3 to 4. But the above air column is having the temperature of 5 or 7 degrees Celsius. Means in normal case when we move up, the temperature decreases, but here during long winter nights, due to excessive radiation, what is happening? As we are moving from surface towards upper atmosphere, the temperature instead of decrease, it is increasing, and this is only considered as radiational inversion. Then after, if we talk about the valley inversion, valley inversion take place during night. How? This is mountains and this is valley. So during daytime, the valley is also getting heated up and the mountain slope also. So the air which is being heated up will move over the slope. But when the sun will set during night, the air over the mountain slope will become more heavier, or you can say they will cool down very rapidly due to normal lapse rate. Now as we know, cold air is heavier than the warmer air. So during night the cold air will subside down in the valley, the cold air, and will take the place in the valley. The warmer air which is present in the valley is going to be lifted up. Means when a person will start moving from valley towards the mountain, the temperature instead of decrease, it will start increasing. Means the temperature of air over the mountains during night are more than the temperature of air which is present in the valley, and this is considered as valley inversion. If we talk about the type of winds, these are only known as anabatic winds and katabatic winds. During daytime, due to heating up, when the air is going to move up from the valley towards the mountain, it will be considered as anabatic winds or valley winds. But during night time, when the winds are going to come down along the slope in the valley, they will be considered as katabatic winds or mountain winds, just like land breeze and sea breeze. Clear? Now moving on to the advection inversion. Advection inversion take place due to movement of a cold air over the warmer surface or a warm air over the colder surface. means due to movement of wind. Suppose the surface is warm, so the air over the surface is also warm. But when the cold air will invade in the area of warm air, what will happen? The cold air is heavier and the warm air is lighter. So warm air is going to lift up. Now when the warm air will be lifted up, the cold air will acquire the place of warm air. So basically, now again, when we are going to move in the atmosphere, what will happen? The temperature will increase instead of decrease, and this happens in the temperate latitudes or the mid latitudes where fronts are formed. That's why the advection inversion are also considered as frontal inversion. Simple. Understood? So in this way, the temperature inversion process take place in troposphere, and basically if we talk about our layers, the temperature inversion case in stratosphere take place neither in troposphere nor in mesosphere. Clear? Now moving on to the mesosphere part. Again in mesosphere, when we will move up, the temperature will decrease instead of increase, as because the density is again decreasing, and when density will decrease, the temperature will decrease. And over mesospause, the temperature reaches to -90 to -100 degrees Celsius. Second thing, in mesosphere, the monoatomic forms of gases are found. Monoatomic forms means single atom, like single nitrogen, single oxygen, single helium or hydrogen. Now the question comes how? And basically in our atmosphere, the gases are present in diatomic form, H2, N2, O2. So how? So these particles are basically the ionized particles. The solar radiation which is coming from sun to earth, that radiation is ionizing the particles, means either that radiation is turning these particles in positive or negatively charged, and due to this only you can say the ions of these gases are present here. That's why they are monoatomic in nature. And the third most important thing, meteors start burning after entering in mesosphere. Before that, they don't burn, which you say them as shooting stars. How? So as we move up in the atmosphere, the density is decreasing. But if we reverse it, and as we move down in the atmosphere, the density will increase. Now when the density will increase, automatically the friction is going to increase. When the friction will increase, they will start burning, and the amount of oxygen is also increasing. That's why the burning of meteors start from mesosphere. Now the question in your mind, sir, why we are not telling them as meteorites? So see, they will reach to the earth's surface or strike to the earth's surface. It's not necessary. They can burn in atmosphere and turn to ash. So that's why we are giving it the first name meteors. When they will reach or hit the earth's surface, then we are going to consider them as meteorites. Clear? Now moving on to the next, ionosphere. The particles present in this layer get ionized due to incoming solar radiation, and these ionized particles are used for radio communication. Means you can say TV, FM, DTH, satellites, phone, radar, each and everything, all the communication activities take place with the help of ionosphere, and the satellites which are placed for our communication, they are also placed in ionosphere. Clear? Second thing, the event of aurora. You know, the aurora australis and aurora borealis, which are also known as commonly northern lights and southern lights, which are the resultant of the magnetic field of earth and the magnetosphere. So the event of aurora also take place in ionosphere only. How? As the ionized particles collide with each other due to the solar wind, the collision leads into spark, and in that spark the abundant gases which are present in our atmosphere, that is nitrogen and oxygen, they burns out. When nitrogen burns, it gives blue color, and when oxygen burn, gives either green or red color. That's why the event of aurora take place in ionosphere, and this UPSC has asked many times about the radio communication also. Satellite communication, satellites are placed in which layer, the event of aurora take place in which layer. So all are ionosphere. Now beyond that, thermosphere and exosphere, when we move, the density is, you can say, nearly negligible, and when the density will be negligible, the temperature will decrease, but the temperature of the particles present in thermosphere is more than 1000 or 1500 degrees Celsius. Temperature of particles is increasing. Why? As we will move near to the sun, the amount of energy will increase, and that amount of energy will increase the temperature. But if we consider the density of the atmosphere, the density is negligible. Means one particle is present here, so another particle is present here over thousands of kilometer gap, and the energy is passing through vacuum. So the average temperature of the layer is in minus, but the temperature of particles are in plus. And you can put the simple logic. The burning of meteor is taking place in mesosphere. If the temperature of thermosphere or the density, either of them, if they were present in thermosphere, so the burning of meteor should have started from thermos only. Why it is taking place from mesosphere? Means neither the density is high nor the temperature is high, but the temperature of particle, again I am telling you, is 1000 to 1500 degrees Celsius, but average is low. And exosphere, basically the outermost layer of the atmosphere where density becomes less than 0.1%, and in this layer mainly the monoatomic form of gases are found, and those are hydrogen and helium. And as our atmosphere is an open system, so the exchange of hydrogen, helium and other gases used to take place between space and this layer. This is the structure of atmosphere, and in this structure mainly till 200 kilometers the atmosphere is directly affecting our life and most important to us. And if you noticed, each and every layer is responsible for some phenomena, and that phenomena is affecting our life, like the weather conditions, presence of air and the density in troposphere is basically, you can say, responsible for maintaining life on earth. The stratosphere, presence of ozone layer, is protecting the life on earth by the harmful solar radiation. Presence of mesosphere is protecting the earth from the extraterrestrial objects which are coming with high speed and it is burning them out in atmosphere only or in the way. Otherwise they will hit the surface and do you can say mass scale extinction or large scale devastation. And the ionosphere, this layer is helping us in communicating the things, communication and the event of aurora. So every layer is having a significant characteristic and significant role in our life. So in this way, the structure of atmosphere comes to end, where we have seen the importance of each and every layer. And mind it, on every year basis they are going to ask you, and they ask either direct questions or indirect questions, and you have to keep them in mind to answer the future questions and the other topics also, because they are related to this only. So we will meet in the next class with another important topic of atmosphere, that is general circulation of atmosphere or atmospheric circulation, in which we are going to deal with temperature belts, wind belts, pressure belts, jet streams, Rossby waves, geostrophic winds, trade winds, westerlies, all these. So we will meet in the next class. Till then, thank you. Have a nice day.